the next topic in this lesson is about levers. So levers are the simplest kind of machines which we know in our day-to-day life. Okay, so as you assume, it is nothing but it is a straight rod which is bent and it is capable of moving around a point. Okay, that point is going to be fixed. So using this we can do many works. Okay, you all know what is a levers is. So the point, the fixed point where we are able to rotate our rod is called as your fulcrum, and the other end of the rod where you are going to move, where you are going to apply your force is called as your effort point, and the other end where you are going to move your load is called as the load point. So now looking at your principle of lever, before going into it we have to note down certain things. Now listen, the three classes of your levers is shown: first order, second order, and third order. So in your first order you can view your fulcrum is at the center and the effort which I am going to apply is at this corner, and this is your load. Now the length between, or the distance between your fulcrum and the effort is called as is your effort arm. Similarly, the length between the fulcrum and your load is called as is your load arm. Is it clear? The distance between your effort and the fulcrum is called as your effort arm, and the distance between your fulcrum and load is called as your load arm. Now look at this one. In this one you can find your fulcrum is at this end. So the distance between fulcrum and load, this is your load arm, and this one is your effort arm. So you can see your effort arm is bigger than your load arm. Now for third class, this is the distance between fulcrum and effort arm, and this one is the distance between your fulcrum and the load, and it is called as your load arm. So here you can find your load arm is greater than your effort arm. So all these three will change depending upon your class of lever. So they're not going to be the same. For your first class of lever, your effort arm and load are going to be same, whereas in second class your effort arm is greater, and for third class your load arm is greater. So before going into the detail of it, first we have to know what you mean by the principle of levers. Levers work on a principle called as momentum. Why? Because it's going to be fixed at one point, and whenever you apply the force, a force and an opposite force exhibits in the other direction, so which can produce us a rotation among it. So we will be using the principle of momentum, and it clearly states the momentum produced in the clockwise direction must be equal to the momentum in your anti-clockwise direction. So your clockwise momentum of a load about the fulcrum must be equal to the anti-clockwise momentum of your effort. So momentum formula, so for your momentum formula here we will be using load into load arm into effort arm. So let me take your first class of momentum, lever. So here load into load arm, this is your load, and this is your load arm. Next one is your effort, and this is your effort, and this is your effort arm, and this is load, and this is your load arm. So for load arm it is F into B or L, and for effort arm it is AF. This is FB and this is AF. That is what I'm going to use here. Okay, load into load arm, effort into effort arm. Now what you do, you just try to arrange them. Load by effort is nothing but FA divided by FB. So FA means effort arm and FB means load arm. So can you recollect this alone? This alone? What is this? It is nothing but your mechanical advantage. So I can obtain a relation which states that mechanical advantage is nothing but effort arm divided by load arm. So mechanical advantage, we have one more formula here. Your mechanical advantage also has this formula, which is nothing but effort arm divided by load arm. So based on this, you can classify your lever as your force multiplier, or a gain in your velocity, or just a normal a lever in which you can change the direction. So all these things we'll be using in our next topics. Okay, now look here. As I told you before, mechanical advantage is equal to effort arm by load arm. So depending upon the ratio, if effort arm and load arm are going to be equal, then mechanical advantage is 1. If mechanical advantage is 1, what is the only thing you can do? You can change in the direction of your effort. If mechanical advantage is greater than, if your effort arm is greater than load arm, therefore mechanical advantage is greater than 1. If it is greater than 1, we call this as your force multiplier. If effort arm is less than your load arm, then mechanical advantage is less than 1, where it will act as a gain in speed. Listen, first one, change in direction. Second one, force multiplier. Third one, gain in velocity. Okay, you can gain in your velocity. All these three I have discussed in your first video, the very first video we discussed. So that is what we are going to implement here again. So now coming back to your kinds of levers. So in your kinds of levers, the first one is your class 1 lever. So in your class 1 lever, you can see your fulcrum is at the center, the load and effort are in the opposite direction. So what you can infer from this, now you can infer this is your effort arm and this is your load arm. So they are going to be equal. If they are equal, mechanical advantage is also 1. As per your principle of motion, mechanical advantage is 1 means velocity ratio is also 1. So that is what it is given here for an idle class of lever. So as I told you before, if your effort arm and your load arm are going to be equal, therefore your mechanical advantage and velocity ratio will be equal to 1. So in that case, the example will be physical balance, because both the arms will be of equal length. But not every case you can find your effort arm and load arm going to be equal for your class 1 lever. Sometimes it may change. So as per, you can also change your velocity ratio and its gain in speed. So now look at this. So when the lever of class 1 has an effort arm shorter than your load arm, so in that case it will become mechanical advantage and velocity ratio will become less than 1. So in that case it is used for your gain in speed. So if at all they are going to, listen here, okay, if it is going to be less than 1, then it is used in gain in speed, so which indicates the displacement of the load is more compared to the displacement of the effort. So the example in this case will be pair of scissors. Okay, pair of scissors, if you see, the effort which you are going to apply will be very small and the length of your effort arm will also be very small, where it is a fulcrum, the point where actually the screw is supposed to be. Okay, so you take your scissor, the center point where you have fixed with your screw is your fulcrum, and after the screw, the handle part is our effort and the remaining blade part is our load arm. So it is an example of your gain in speed. So the next one is a long handle oar. So now this person who's riding, who's just rowing a boat with a long handle oar, is an example of your increasing in your speed. Okay, it's your force multiplier. So in this case, you can see clearly here, your load arm is bigger comparing to your effort arm. Your load arm is bigger comparing to your effort arm. So what happens, he is able to move his load. What is the load over here? It is the water. So using the oar, he is able to move a lot of water by applying a short effort. So this will act as your gain in velocity. This will act as your gain in velocity. So the next class of lever is your class 2 levers. So in class 2 levers, you can clearly see the load is in its center. The load is in its center. So what you can infer, generally your load arm will be always shorter. Okay, it will be always shorter than your effort arm. Yes or no? Your load arm will be always shorter than your effort arm. Why it is shorter? Can you see the distance for fulcrum and the load? It is smaller comparing to the fulcrum and the effort. So now we'll go into it. So in this type of levers, the fulcrum and the effort are on the two ends of the lever and load is somewhere in between them. Okay, here the effort arm is always longer than the load arm. Therefore, the mechanical advantage will be greater than 1. So as per your idle machine concept, mechanical advantage and velocity ratio are equal. Therefore, velocity ratio will also be greater than 1. So mechanical advantage and velocity ratio of class 2 levers will be always greater than 1. So this is one important point. What they will ask, for which class of lever you will have your mechanical advantage and velocity ratio always greater than 1, it is for class 2 liver. Whereas in case of class 1 liver, all three categories is possible. You can obtain a force multiplier, you can obtain a gain in speed, you can also obtain the change in its direction of your effort. All three are possible in your class 1 liver. In class 2 liver, we will use only one this. In other words, class 2 lever or always act as your force multiplier. They are always act as your force multiplier. The questions will come, which class of lever will act as a force multiplier? The answer is class 2 levers. Okay, it can only act as a force multiplier. Only act means it is your class 2 levers. The examples are given here: the bottle opener, a nutcracker, a bar to lift a load, and wheelbarrow. So the next one is class 3 river. So automatically who should come in the center now? Effort, yes or no? So in your class 2 it is a load in the center. In class 3 it is the effort which is in the center. Okay, so mechanical advantage and now you can see, I'll tell you how it works. Listen. Okay, since the effort is in the center, look here, effort in the center, this is your effort arm and this is your load arm. So now what can you infer? Your effort arm will be always less than your load arm. Your effort arm will be always less than your load arm. So what is the automatic solution of this? Your mechanical advantage will be less than your 1. So therefore mechanical advantage and velocity ratio will be less than 1. So this means it will act as your gain in speed. Okay, it will act as your gain in speed. Class 3 levers will act as your gain in speed, and these are some of the examples. Your sugar tongs, your forearm used in lifting a weight. So all these are example of your class 3 levers. And apart from that, here they have given some of the examples of your each sort of lever. Class 1 lever, the action of nodding of your head. Okay, boys, 10th standard, you will be getting questions like this. They will give an example, ask you to identify which class of lever, or they will give a picture, ask you to identify the class of lever and to mark your effort, load and fulcrum. All these three will appear. Or give an example and give an example of class 2 lever, mark all the 3 points will be asked in your question papers. So now let us see for your class 1 lever. Class 1 lever, the example is your nodding of your head. You can see the fulcrum is in it's our center part, that is your spine, and the load is in our face and the effort is given back of our head. Now the next one is class 2 levers. Class 2 levers, all these are in our body parts. Okay, raising a weight of the body on your toes. So the fulcrum will be your the toes, the load will be your entire body, and the effort will be going upwards, that is by the muscles. And class 3 lever is as I told you before, using an object to lift your forearm to lift a heavy object. So load is in your hands, that is in your palm you will keep, and the fulcrum will be the in between bones, and the effort will be from your biceps. Okay, so this is how it will work. Go through these lessons.